Okay, today we're going to do the graham cracker lab. The materials that you're going to need: frosting, wax paper strip, spoon, 2 graham crackers, a cup filled about halfway with water. Okay, the first boundary that we're going to represent is a transform boundary. You're going to take your graham cracker, break it in half. You can actually see down the center, and it gives you an easy way to break it in half. These are going to represent your tectonic plates. So with the transform boundary, if you recall, these 2 plates are side by side, and they rub against each other. So focus on what is happening to the 2 graham crackers or tectonic plates as they move past each other. What do you think would happen on Earth when this occurs? Okay. The sliding that's happening right here actually causes earthquakes on Earth, and fault lines like the San Andreas Fault in California occur along these boundaries. If you look, here's a picture of the San Andreas Fault in California, and it occurs where the Pacific Plate and the North American Plate slide past one another. That's why there's a lot of earthquakes on the western coastline of the United States. It's all because of that transform boundary. Okay, the next thing we're going to do is model a divergent boundary. So you're going to need to get some frosting and put it on your wax paper. And 2 spoonfuls, I think, should be enough. We'll see. Kind of spread it out. As we're doing this, let's think about what the frosting would represent. It's a semi-solid, has plasticity, so what layer would that be? Okay, so we're going to go with 2 spoonfuls. Okay, so the frosting we're going to say is our asthenosphere. Okay, remember, on top of the asthenosphere we have the lithosphere. So you're going to put the 2 pieces of graham cracker on top of your asthenosphere. So the lithosphere is on top of the asthenosphere. I'm going to push down firmly, but not so firm that my graham cracker cracks. And I'm going to separate the 2 plates. Okay. So, if you look close and see what's formed right here. Okay. This would be that molten or melted rock of the asthenosphere that comes up. It gets pushed up out of the earth as the 2 plates separate. Okay. This is actually an example of a ridge, and ridges can form in the ocean or they can form on land as well. If it happens in the ocean, we call this sea floor spreading, and you can go ahead and look at that. This is an underwater picture of sea floor spreading. The molten rock is being pushed up out of the earth as the 2 plates separate. And this is what might look like on land, where we have a ridge being created from divergent plates. Okay. The Mid-Atlantic Ridge runs from Iceland all the way through to the South Atlantic Ocean. Most of that's underwater, so we would have had that seafloor spreading going on. Some of that, like in Iceland, which is pictured over here, happens on top of the land. Okay, now we're going to start talking about convergent boundaries, and we have two types of convergent boundaries that we're going to learn about. Remember, we have continental crust and we have oceanic crust. Continental crust is less dense, so it floats above, and then we have oceanic crust that is more dense and it's on the bottom. So I'm going to take my graham crackers off of the asthenosphere and just lay them like this. And I'm going to get my spoon back. I'm not putting any more frosting on, but I'm going to kind of get it back towards the center as best as I can. And kind of even it out some. And I might have to use my finger. I'm going to get a little bit off of the tectonic plate there, the lithospheric plate. Okay, so we are going to model, first of all, continental crust versus oceanic crust. Okay. So we have continental versus oceanic plate. Remember, this is a convergent boundary, so convergent boundaries come together. So this is what would happen when those convergent boundaries come together. It's where we have a convergent boundary, and this would be continental versus oceanic. When continental plates go over oceanic plates, we have what is called subduction. The less dense continental plate comes over the more dense oceanic plate. So, again, when this occurs, we have subduction. That means the continental plate comes over the oceanic, and what is called a trench is formed. And a trench is a very deep hole in the ocean. So the ocean floor just automatically gets extremely deep. So either a trench is formed, or also, as you saw with the model, okay, see how some of this molten rock came up? That could create a volcanic arc. A volcanic arc is just a mountain volcano. Alright. So next, we're going to have continental versus continental. And you're going to save this graham cracker right here, because this is a graham cracker that you and your partner are going to get to eat here in a second. Okay, so we're going to use the other side of our wax paper, and you're going to get a new graham cracker. Okay, this graham cracker, I'm sorry, but you don't get to eat unless you just really want to. Okay, so we're going to break the graham cracker in half. Then you're going to put the end of the graham cracker, both ends of the graham cracker, in the water, not the whole thing, in the water for about 3 seconds. So 1 1,000, 2 1,000, 3 1,000. Okay? So here we have, okay, here we have our continental versus continental plates, and hopefully yours doesn't break like mine just did, but if it does, just kind of push it up like I did. So we're going to push the two wet sides of the plates together so they're converging. Okay. See how the lithosphere plates came and got pushed up? Okay. This, of course, would probably cause an earthquake to occur, but also this continental collision, so this convergent boundary, also tends to create mountains. So a lot of the mountains that you see on Earth today are created from that convergent continental boundary. Okay. Thanks for watching. I hope you enjoy the lab. You can eat, I don't think you'd want to eat the wet side, but if you want to, I guess you can. You can eat whatever frosting is left over, and you can also eat your plate. Thanks.